All right, this is, I believe, the last assignment before the reviews and whatnots. So this is kind of close to a review itself. This is everything that you need to know about integrals, definite integrals, and using U substitution. So let's go ahead and get started. So if you don't need to use U substitution, don't. If you do. It's up to you. So here, this one, you don't. This is the same thing as saying 5 and then a denominator of x as such. I know what this is. This is a bunch of ln's. This is going to be a bunch of ln's here. Sorry about that. The integral of this would create a 0, so this is going to be the ln of x. That's the integral of that x. There's that 5, and then there's a plus c. Yeah, so that's what this is going to be about. There's going to be a bunch of ln's in this assignment. So, I know we talked about it before. So usually, again, what you do with that x, whatever the case may be, is you add 1 to that exponent. However, when it's a -1 and I add 1, that would create an exponent of 0. Not okay. So instead, that's going to be an ln of the absolute value of x. All right, so here, this is going to require just a teensy-weensy bit of U substitution. U is equal to x plus 1, so the derivative of U is 1. That's exactly what I wanted. Okay, that's exactly what I wanted. So this is the same thing as saying the integral of U to the -1 du. So in this situation, that is going to be the ln of U. And so going full circle, that is the ln of x plus 1. So U, in this case, is 3x plus 5. I wanted that to be a 2. So that requires a 2/3. Just more of the same stuff. Then the indicator is this is an x to the 4th, this is an x to the 3rd, so this is going to turn into that. So the U is going to be the x to the 4th portion. Exactly what we wanted. So that eliminated that entire top side. That is the derivative. So that was eliminated, and that bottom part is a U. Okay, here I separate it. And again, what I mean by that is this. I'm able to separate numerators. Can't separate denominators. I'm able to separate numerators. So this is going to be the integral of x minus 4x to the negative 1. That's what this problem is. There's no u substitution necessary because we can just handle business. So u substitution, but still, this is just a trick. That will get eliminated. No extra pieces. Nice and tight. All right, so this is a y and this is an x. So they want the to find the solution. Graph 3 solutions. I think I did this on the answer key. 3 solutions, huh? Okay. 1 through that point. Okay. So that means let's go u. So I am integrating this, which is going to be u to the negative 1. Okay, so that is all of your solutions. Whatever you want to make C, that's a solution. All right, and they want one of the solutions to be equal to 0, 4. So I'm going to get right into the math of this. So again, this is what y is equal to. If you integrate a derivative, okay, if I integrate a derivative, you're equal to y. So y is equal to that. So in essence, they're saying y is equal to ln of 0 squared minus 9 plus c. Okay, so this is the ln of negative 9, which is going to be positive 9 plus c. So c is going to be equal to negative ln of negative 9. I don't know if I got that as, excuse me, not of negative 9, because you can't take a ln of a negative number. That's why it's an absolute value. Right? Positive 9. So c is equal to approximately, you can keep it like this, So this is approximately equal to negative 2.1972. Approximately. Exactly, it'd be the negative ln of 9. Okay, so that is exactly one solution. I feel like I got a different answer for some weird reason. So y is equal to ln x squared minus 9, absolute value, minus ln of 9. That goes through that point. I'm just going to see if that's true. So the ln of x squared minus 9, ooh, that's an absolute value, I'm sorry. Let me start this all over. So I got the ln of the absolute value of x squared minus 9, close the absolute value, close the ln minus ln of 9. Let's just see if this ticks. Yes, that goes to the point 0, negative 4. Or excuse me, 0, 4. No, it doesn't. Yeah, it does. No, it doesn't. Oh! That's why I had everything different. I'm dumb. I'm dumb. You see my mistake? This is true, but the y value is 0 and the x value is 4. So this is the ln of 16 minus 9. But again, for some strange reason, I feel like I have a different answer. And I had the correct answer before. And no, I didn't. Let's try this. Nope. Do you see my mistake? This is an X and this is a Y. Man, where did I learn math? I'm ashamed. All right, so Y is 4. There we go. Yeah, there. Okay. So this is going to be the ln of 9 because it's the absolute value. And so, yes, this is exactly what I had. There it is. It is correct on the answer key. Oh, okay, so this is the solution. So ln of absolute value x squared minus 9 plus c, which would be plus 4 minus ln of 9. There we go. That will go through the point that we wanted. That better go through 0, 4. Ha ha, it does. Yay. Okay. Okay, that was that equation right there. And it looks like they hit 3 and negative 3. Oh, sorry. They don't line out, they square root out. All right, so that is that one. That's the critical one that I needed to graph. And then if I just change this C, what I can do is I can graph other things. So if I change that C, oh, crap. Right? Yeah. So if I change that to like ln of absolute value of x squared minus 9, let's turn that that y value, let's say I want it to go through the 0.6, and so that would mean this 4 is now a 6 minus ln of 9. I think it'll have the same x values, and it'll just be higher and steeper. So that was the original. This one should go dip at the same spot, yep, same spot, yep, and there you go. So whoop, whoop, like that, and that would be where y is equal to the ln x squared minus 9 plus 6 minus ln of 9. Okay, and then all we have to do is just graph one more of these things. So again, turn turn that y value into anything else that you want. So y is equal to ln x squared minus 9 plus 2 ln 9 would be this, and it would go you have to have the sound effects. You have to say whoop. So just quadruple prove that. This is again what ln absolute value x squared minus 9. Wasting too much time on this problem. Plus 2 minus ln of 9. There it is. Oh, it's way down. Whatever. No. It'll take me enough to figure it out. Good enough. Okay, back to starting things and figuring out the solution, which is, again, get it all the way back down to the original f, not an f prime or something. So, f prime in this situation, I see that this is what, 2x to the negative 2. All right, 2x to the negative 2. So the derivative of this is going to be x to the negative 1, negative 2 plus c. All right, that's the first derivative. And then they give me a situation where they go f prime of 1. So this is negative 2 over 1 plus c is equal to 1. And so c is equal to 3. Okay, off to the races. Here is where an ln is going to come into play. So the first derivative is the integral of that. So this is going to be negative 2 ln of x plus 3x plus c. It gave me a value of 1. Equal to 1. The thing about a picture of an ln, the picture of an ln looks like this. Again, so this has a point of 1, 0, just like an e. It's the opposite of an e, which has a point of 0, 1 kind of idea. And so this is a 1, 0. So if you plug a 1 into an ln, you're going to get an answer of 0. So this negative 2 ln of 1 is 0. So this is 0 right there. And so this is 3. So this is going to be what, negative 2? Oh, and they say x is exclusively bigger than 0, so I'll just say x, rounding brackets. Again, that is when x is greater than 0. Okay, let's evaluate this derivative. Okay, ln of 1, again, as I said, is equal to 0. Notice I do have a 1 over x. Okay, so ln of e is 1 because it has an exponent of 1, so that'd be 1 plus 1. ln of 1 is 0, so this is in essence 1 plus 0. And so again, this is eliminated. It's eliminated, and so yeah, everything is taken care of. Whoa, what the heck just happened there? Try that again. Okay, I don't know if you can quite see it, but the edges are right there and right there. So that goes from 1 to 3. So we want to find the area from 1 to 3 of this picture. Same thing right there. ln of 1 is 0. I hope this doesn't have any jumps. I don't think it does. I don't think they're being cruel. So this is what, x squared plus 4 divided by x. From 1 to 4. Yeah, so it's continuous, 1 to 4. Okay. Think. Just gotta think. I'm gonna check my answer key here real quick. Oh, I'm stupid. Yeah. Okay. I'm silly, and I just don't see it, and I forget my original thought of I can separate numerators. Making my world way easier in a lot of different situations, including this one. All right. So ultimately, this has a slant asymptote. This has a slant asymptote, and with a plus 4 or something like that. And so, but this picture is looking like this. And so we are going from 1 to 4. And so we're looking for this area right here. All right, so so I am integrating from 1 to 4 of this right here, which is x squared plus 4 divided by x. Again, that's incredibly hard right there. So this is, I'm going to separate it. So this is x squared over, separate numerators. So this is x squared over x plus 1/4 of 4 over x. All right, so this is 1 to 4 of x. And then this is 1 to 4 of x to the negative 1, okay, outside of 4. All right, so this first one is x squared 1/2 from 1 to 4. And this is going to be the ln of x. Again, from 1 to 4. So this is 1/2 of 16 minus 1 plus 4 ln of 4 minus 0. So this is what, 15 over 2 minus 4 ln of 4. And so that could be the answer. Again, ln of 4 is the same thing as saying 2 like this. So you could bring that out. So this is 8 ln of 2. Or you could go vice versa. You could put the 4 in, and you could say that this is the ln of what? Whatever 4 to the 4 is. So the 256, you could say that it's 256. A bunch of different answers here. I'm totally cool with this one right here. However, I believe the book would probably say that this is 15 over 2 minus 8 ln of 2. I think that's probably what it would be. Okay, what is that? Okay, indefinite integral, not a big deal. So use substitution. So f is the antiderivative of f. So f prime, that's saying f prime is equal to f. All right, so antiderivative, so that's the integral of f is equal, little f is equal to big F, antiderivative. Okay, so the integral, okay, if f of 1 is that, okay, so f is the antiderivative, and so what is f of 6? Not a big deal. So what we're going to do is we are going to begin by taking the antiderivative of little f, and that's going to be equal to f. Begin. Okay, so we're going to just straight up start with that portion of the problem. And so this is the integral of 2 ln of x to the 4th divided by x. All right, use substitution is ln of x. That means the derivative is 1 over x, which is there, so that eliminates that portion, and now it's just a regular problem. I needed a 2 on this, and so I need to multiply by 2. So since I'm taking that out. So this is 2 integral u to the 4th. Okay. So we have a base formula now. And it looks like all of our answers are decimals and things like that. So I'm not going to break myself understanding like what the fractions are and things like that. I'm not really going to break myself to keep things in ln's and stuff like that because the answers are in decimals. So it's assumed that you have a calculator. All right, so here, this is f. And so now they give me an initial condition f of 1, which is going to be 2/5 ln of 1, that's a 0, to the 5th plus c is equal to 0. So again, ln of 1 is 0, so this is 0, which this is 0, making c equal to 0. So that updates my f function to be just straight up 2/5 of ln of x to the 5th. And now ultimately the question that is being asked is what is f of 6? And so ln of 6 to the 5th times 2/5. $3,868. 387. Now that's